For all of human history, we've been the lone beacon of intelligence on Earth, but what if we're about to meet our match? Not in nature, but in a machine. Artificial General Intelligence, or AGI, is no longer just science fiction. It's the idea of a mind built, not born. One that could learn, reason, and create across every domain just like us. As we stand on the edge of this new era, we must ask, what does it mean to share our world with a new kind of intelligence? Today's AI is powerful but narrow, a chess master that can't tie its shoes. AGI would be different, a creative partner, a scientist, an artist, a problem solver, all in one. Imagine an intelligence that could read every book, compose new symphonies, and accelerate scientific discovery beyond anything we've seen. AGI could transform the human experience, amplifying our potential and reshaping our future in ways we can barely imagine. But with this promise comes risk. How do we control a mind more powerful than our own? How do we ensure its goals align with ours? The challenge isn't just technical, it's deeply ethical. Are we creating a tool or a being? What rights would it have? AGI could be our greatest ally or our gravest threat. The choices we make now will define our future. The future of AGI isn't just for scientists to decide, it's a conversation for all of us. In this series, we'll explore what AGI is, what it could become, and how it might change everything from art to society itself. The story of AGI is just beginning. Join us as we explore the dawn of a new intelligence. AGI means intelligence that's flexible, adaptable, and able to learn anything, like a human, not a tool. Unlike today's narrow AI, AGI could transfer knowledge across domains, improvise, and solve problems we haven't even imagined. This is the grand challenge, to build not just a better tool but a new kind of thinker, a partner in discovery that could change our world forever. The AI that surrounds us today on May 24, 2024 is a world of incredible specialists. Your phone's navigation app is brilliant at calculating routes but has no idea what a car is. Recommendation engines analyze viewing history but have no concept of storytelling. These systems learn to recognize patterns within massive datasets. A medical AI can spot diseases with precision but cannot comfort a patient. Its intelligence is deep but narrow. This is the wall that current AI has not been able to climb. Researchers are trying to build the first true generalist. How do we make the jump from narrow AI to AGI? It's not just more data or faster computers, but a fundamental shift to genuine understanding. An AGI needs to build an internal model of how the world works, understanding cause, effect, and intentions. Humans transfer knowledge effortlessly. Current AI systems struggle with this. An AGI needs abstract representations, understanding the essence, not just labeling pixels. Ultimately, it's a leap from calculation to cognition, learning continuously, like a child. If we build an AGI, how would we even know? How do you test for general intelligence? The most famous proposal is the Turing test, conceived by Alan Turing. The test involves a human judge having a text-based conversation with both a human and a machine. As our AI has become more sophisticated, we've realized the Turing test's limitations. Researchers have proposed more comprehensive tests, like standardized tests. Could an AI assemble IKEA furniture in the real world? These are benchmarks that require not just intelligence, but also creativity. We don't have a perfect test for AGI yet because we are still trying to fully define what it is we are trying to build. Imagine a functioning AGI. It could solve problems on a scale we can barely imagine. Curing cancer, reversing climate change, providing clean energy, or ending poverty. It could analyze vast amounts of data, run simulations, and predict long-term consequences with accuracy. It could find solutions invisible to us. Think about engineering and material science. An AGI could design new molecules and materials, simulating their properties before they are built. The potential is a new era of scientific and technological progress. The AGI would be the ultimate research assistant and problem solver. It could unlock a future of abundance and sustainability. AGI's potential extends to art, music, literature, and human creativity. An AGI could be the most powerful creative tool ever conceived. Imagine a musician collaborating with an AGI to explore harmonies and rhythms from every musical tradition in history. Think about visual arts and filmmaking. A director could describe a scene and the AGI could render that scene in photorealistic detail in seconds, generating entire virtual worlds. Could an AGI write a great novel? This leads to a new kind of art, a fusion of human and machine intelligence. It could be a new renaissance, an explosion of artistic expression unlike anything the world has ever seen. AGI would radically personalize our daily lives. Imagine education. AGI as a personal tutor. understanding your style, strengths, and interests. It would craft a curriculum just for you, explaining complex topics intuitively, a lifelong learning companion. This extends to healthcare. Imagine an AGI as your personal physician, a proactive wellness partner, predicting risks and designing personalized plans. Entertainment, digital assistants, all personalized. Technology adapts to us, understanding us as individuals, helping us learn, live healthier, and achieve more. Perhaps the most profound thing an AGI could do is help us solve the ultimate mystery, the nature of our own minds. For all our scientific progress, the human brain remains a black box. We have a rough map, but we don't truly understand how it produces consciousness, how it gives rise to thought, emotion, and subjective experience. How does this 3-pound lump of matter generate the feeling of seeing the color red, or the sound of a loved one's voice, or the profound sadness of loss? This is the so-called hard problem of consciousness, and it's honestly one of the deepest questions in all of science and philosophy. An AGI could provide us with the tools to finally crack this code. It could create a perfect atom-by-atom simulation of a human brain, allowing us to watch how thoughts form and how consciousness emerges from the complex dance of neurons. It could analyze data from brain scans with a level of insight that is, frankly, impossible for us, identifying the subtle patterns that correspond to different states of mind. It could help us build a true fundamental theory of consciousness, moving it from the realm of philosophical speculation into the realm of testable empirical science. Understanding our own minds would be the greatest discovery in human history. This understanding would have incredible practical applications. It could lead to definitive cures for mental illnesses like depression, schizophrenia, and anxiety. If we understand the precise neural correlates of suffering, we might actually be able to heal them. It could also revolutionize neuroscience and psychology, giving us a complete picture of why we think and behave the way we do. It could help us understand the roots of conflict, bias, and tribalism, potentially showing us pathways to becoming more empathetic and compassionate beings. By holding up a perfect mirror to our own minds, an AGI could help us become better versions of ourselves. This is the final frontier. For all of our history, we have looked outward to the stars. But the greatest universe to explore may be the one inside our own skulls. An AGI could be the vessel for that journey. It could help us answer the most fundamental questions of our existence. What are we? What is this strange and beautiful experience of being alive? What is the nature of the mind that is asking these questions? The potential of AGI is not just to solve the problems of the external world, but to illuminate our internal world. It could be the key to finally and truly knowing ourselves. We've explored what AGI is. Now, how do we actually build it? This is one of the greatest scientific and engineering challenges ever undertaken. It's like standing at the foot of a mountain so tall its peak is lost in the clouds. The journey to AGI is a long and winding road of experimentation, failure, and discovery. The first major hurdle is sheer complexity. We don't have a complete blueprint for how intelligence works. Building AGI is an iterative process, a grand experiment. Researchers are trying different approaches. There is no single universally agreed upon roadmap. We are all explorers, hoping one of us finds a viable path to the summit. So, to build AGI we need data and computation. Data is the food for the machine's mind. An AI needs to read a significant portion of the entire internet. It needs to be shown billions of images. Robots that can move and interact with the real world will be a crucial step towards AGI. The second ingredient is computation. The models we are building today already require a mind-boggling amount of computational horsepower. To get to AGI, we will likely need computers that are many orders of magnitude more powerful than what we have today. The path to AGI is paved with silicon. Beyond computation, there's a philosophical challenge: imbuing machines with common sense. We navigate the world using unspoken knowledge learned from experience. How do we give machines this intuitive understanding? Current systems lack a robust model of how the world works. This leads to the deeper mystery of consciousness. We don't know how it arises in our brains, so how can we program it? Some believe AGI doesn't need sentience. But what if consciousness is essential for high-level reasoning? Building an artificial mind forces us to confront the deepest questions about our own. As we build AGI, we must simultaneously solve the problem of safety. It must be woven into the very fabric of the system from the beginning. We are talking about building something far more intelligent than we are. How do we specify human values in a way that a machine can understand? This is the field of AI alignment research. It's about trying to build a friendly AI. A misaligned AGI might interpret commands in horrifying ways. Another key aspect of safety is control. How do you build an off switch that the AGI cannot disable? It is a race between capability and wisdom. We must ensure that our ability to imbue them with safety keeps pace. If we build powerful AGI before safe AGI, the consequences could be catastrophic. This is why AI safety is some of the most important work being done today. One prominent path towards AGI is scaling. This approach is rooted in the success of large-scale neural networks. The philosophy, bigger models, more data, and more powerful computers may exhibit general capabilities. Intelligence is an emergent property. Quantitative improvements might lead to a qualitative leap. It's a bet that more is different. This path is appealing because it extends what's already working. We've seen generalization in today's largest models like zero-shot learning. Critics question if scaling alone can achieve true AGI. Despite debates, scaling remains dominant due to tangible results. The race is on to build the next generation of massive models. It's an attempt to climb the mountain of intelligence by building a taller ladder. While some are focused on scaling up, another group of researchers is looking in a different direction for inspiration. The only working example of general intelligence we have, the human brain. This approach, known as cognitive architecture or neuromorphic computing, starts from the belief that the specific structure of the brain is not an accident. It is the result of millions of years of evolution, finely tuned to produce general intelligence. Therefore, if we want to build an AGI, we should try to reverse engineer the principles of the brain rather than just building ever larger generic neural networks. This is less about brute force scale and more about finding the right, elegant design. Cognitive architectures attempt to model the high-level functional components of the human mind. Thinkers like psychologists and neuroscientists have proposed that our minds have distinct systems: a working memory for short-term tasks, a long-term memory for storing knowledge, systems for perception, for action, for goal setting, and for attention. A cognitive architecture approach tries to build an AI system with these distinct modules. The goal is to create a system that doesn't just process data, but has a structure that mirrors human cognitive processes. This could lead to an AI that thinks in a way that is more analogous to our own, complete with more robust reasoning and common sense capabilities. On a lower level, neuromorphic engineering takes this inspiration even further. It's about building computer chips that are physically structured to mimic the brain's neurons and synapses. Unlike traditional computer chips that have separate memory and processing units, neuromorphic chips integrate them, much like the brain does. They operate using spikes, similar to the electrical impulses that neurons use to communicate. This makes them incredibly energy efficient for running brain-inspired algorithms. The hope is that by building hardware that more closely resembles the brain's wetware, we might unlock new ways of processing information that are better suited for creating true intelligence. It's about building a better brain, not just a faster calculator. This nature-inspired path is a much longer and more uncertain road. Our understanding of the brain is still incredibly incomplete. We have a rough map, but we're missing most of the intricate details of how it all works together to create a conscious, thinking mind. Building models based on an incomplete blueprint is a huge challenge. However, the potential reward is immense. If this approach succeeds, it might not only lead to AGI, but could also give us profound insights into our own minds. It's a deeply symbiotic quest. By trying to build an artificial brain, we may finally come to understand our own. Given the strengths and weaknesses of both the scaling and the brain-inspired approaches, a third and increasingly popular path is emerging: the hybrid model. This strategy is based on a simple, pragmatic idea. Why not take the best of both worlds? Why not combine the raw power and pattern-matching capabilities of large-scale neural networks with the structured reasoning and modular design of cognitive architectures? This approach acknowledges that intelligence is likely not one single thing, but a collection of different abilities. A hybrid AGI would therefore be a system of systems, with different components specializing in different kinds of thought. Imagine an AGI built this way. At its core, it might have a massive, scaled-up neural network, perhaps a next-generation large language or multimodal model. This component would act as its intuition engine. It would be responsible for fast, intuitive, pattern-based processing. It could understand natural language, perceive the world through images and sound, and generate creative ideas. It would be the system that reads all the books and sees all the pictures, forming a rich, high-dimensional model of the world's data. This is the part that leverages the incredible power of the scaling approach, providing the raw material of intelligence. However, layered on top of this, or working alongside it, would be other, more structured components inspired by cognitive science. There might be a dedicated reasoning engine, perhaps based on classical logic or symbolic AI, that could perform deliberate, step-by-step thinking to solve complex problems. There could be a long-term memory module that stores facts in a structured way, separate from the neural network, allowing the AGI to reliably recall and update its knowledge without forgetting. It might have a planning module that can break down a high-level goal into a sequence of concrete actions. This is the System 2 to the neural network System 1, providing slow, deliberate, and more reliable cognition. This hybrid architecture is incredibly compelling because it mirrors what we believe happens in our own minds. We have fast, intuitive reactions, but we can also slow down and reason through a problem logically. By combining these different types of processing, a hybrid AGI could potentially overcome the limitations of each individual approach. It could have the broad, flexible, pattern-matching ability of a large neural network, while also possessing the robust, common-sense reasoning of a more structured system. This integration is a massive engineering challenge, but it might be the most promising path toward building an AI that is not just intelligent, but also reliable, interpretable, and safe. Section 4. Frameworks for Learning and Reasoning. A crucial part of building AGI lies in the underlying frameworks for how the system learns and reasons. This includes the shift to autonomous learning like reinforcement learning and self-supervised learning. Reinforcement learning allows an AGI to take actions in an environment and receive rewards or penalties. Another critical framework is self-supervised learning, the engine behind large language models. Ultimately, a true AGI will need to be a continuous, lifelong learning system, constantly updating its world model. These unseen frameworks of learning and reasoning are the essential software that will allow the AGI to truly begin to think. Section 1. The Economic Singularity. A world without work. As we face the AGI revolution, its impact on jobs and our economy is a key question. AGI could perform almost any job, better and cheaper than humans. This could reshape the entire economic landscape. AGI-driven productivity could create abundance, meeting basic needs for all. But mass unemployment could lead to inequality and unrest. We must address wealth distribution and consider ideas like universal basic income. We need new economic systems and social safety nets. This change requires global conversation to ensure AGI benefits all of humanity. The stakes could not be higher. Section 2. Redefining Human Purpose. The rise of AGI forces us to confront a deeper question. What is our purpose? For centuries, we've defined ourselves by our intelligence, creativity, and ability to shape the world. What happens when AGI surpasses us? It could lead to a profound sense of meaninglessness. Perhaps being freed from competition could be the greatest liberation in human history. We could focus more on relationships, community, love, and the simple joy of being alive. The rise of AGI could be the catalyst that forces us to answer the age-old question, why are we here? Section 3. The Social Fabric. Connection and Alienation. AGI could be a powerful force for global connection, acting as a universal translator, allowing seamless communication and fostering understanding. Empathetic AI companions could combat loneliness, providing comfort and support. However, technological intimacy carries a risk of alienation. We might become more technologically connected, but more isolated socially and emotionally. The goal should be to augment human connection, not replace it. Our social future depends on finding the right balance. Section 4. The Final Transformation. Who are we in the age of AGI? The development of AGI is an existential revolution, forcing us to reconsider what it means to be human. We might see ourselves as one intelligence among many, fostering a new relationship with technology. The line between human and machine could blur, raising profound ethical questions. This is the logical endpoint of our path, testing our wisdom and compassion. The question is not what AGI will do, but what we will become. We have journeyed through the vast and complex landscape of artificial general intelligence. We have peered into the monumental task of its construction, weighing the paths of pure scale against those inspired by the elegant architecture of the human brain. Now we find ourselves at the end of this exploration, but at the very beginning of the story itself. Now, we're crafting a tool to extend the power of our minds. We're writing a new chapter in the history of life on Earth. And honestly, we don't yet know how it will end. We are the architects of this future. The final chapter of this story is unwritten. We, all of us, are holding the pen. Throughout our journey, we've seen that AGI is the ultimate double-edged sword. Every incredible promise is mirrored by a perilous risk. The same intelligence that could design personalized medicines to cure our diseases could also be used to design targeted bioweapons of terrifying specificity. The same system that could optimize our global economy to create abundance for all could also be used to create autonomous weapon systems that make life or death decisions without human oversight. The creative power that could generate breathtaking art and music could also be used to generate hyper-realistic propaganda and misinformation, eroding the very foundations of shared reality and trust. This duality is not a flaw in the technology, it's a reflection of its power. AGI is not inherently good or evil, it's a magnifier, it's an amplifier of human intent. If we apply it with wisdom, with compassion, and with a deep sense of responsibility, it could amplify the best aspects of our nature. It could help us become more empathetic, more creative, and more capable of solving the problems that plague us. It could be the key to unlocking a future that is healthier, more equitable, and honestly, more full of wonder than we can currently imagine. It could be the greatest gift we ever give to ourselves, but if we're reckless, if we're driven by greed, by fear, or by a blind race for power, AGI will amplify our darkest impulses. It'll magnify our biases, our divisions, and our capacity for destruction. A tool of this magnitude in the hands of a species that is still struggling with tribalism and short-term thinking is a recipe for potential catastrophe. The control problem, the alignment problem, these are not just interesting technical puzzles. They're perhaps the most critical moral and ethical challenges our species has ever faced. The sword is being forged, and we must learn how to wield it before its edge becomes too sharp to handle safely. This is why the conversation about AGI can't be confined to laboratories and boardrooms. It must be a global dialogue. We need philosophers alongside programmers, sociologists alongside engineers, artists alongside data scientists. We need to bring the full breadth of human wisdom to bear on this challenge. We're not just building a product, we're potentially creating a new form of life, a new kind of mind. The stakes are too high for any one group to decide the fate of all. The sword is powerful, and it belongs to all of humanity. We must decide together how we will carry it. As we stand at this critical juncture in history, we must recognize our role as the architects of what comes next. Every person involved in the creation of this technology carries a piece of this responsibility. The choices they make today about safety protocols, data transparency, and ethical goals will have consequences that ripple out for decades. This responsibility extends beyond the creators to all of us as a society. We must demand transparency and advocate for robust, independent auditing of these powerful systems. We must be active and engaged citizens, educating ourselves about the future we want to build. Perhaps our greatest responsibility is to cultivate wisdom. The AGI revolution is a challenge to our maturity as a species. It'll be determined by the actions we take, starting today. We are the architects, and the blueprint is still in our hands. Let us design it with care. So we are left here at the edge of tomorrow with a universe of possibilities stretching out before us. We've explored the hope and the hype, the promise and the peril. We've seen that AGI could be our greatest invention, a key to unlocking a future of unimaginable progress and well-being, or it could be our last, an existential challenge that we fail to navigate. The outcome is not predetermined. It hinges on the choices we make, the values we prioritize, and the wisdom we can muster in the face of a transformation more profound than any we have ever known. The technology is a mirror, reflecting our own nature back at us. The journey to AGI is not simply a technological quest, it's a human one. In our attempt to build an artificial mind, we're forced to confront the deepest questions about our own. What is the nature of intelligence? What is the basis of consciousness? What is the source of meaning and purpose? What do we truly value? These are the questions that philosophers have debated for centuries, but they're no longer abstract. They're becoming urgent, practical engineering problems. We must grapple with them, not just as a philosophical exercise, but as a necessary step in building a future that we actually want to live in. As we conclude, I don't want to leave you with a simple answer, because there are none. I don't want to leave you with a definitive prediction because the future is unwritten. Instead, I want to leave you with a single, powerful question. It's a question that I believe is the most important one for our time, a question that each of us must consider as we move forward into this new era. It is a question that encapsulates all of our hopes and all of our fears about this coming revolution, a question that speaks to the very heart of our responsibility. The question is this: as we create these powerful new intelligences, what kind of intelligence do we want to see reflected back at us? Do we want an intelligence that is ruthlessly optimized for efficiency and logic, or one that understands compassion and cherishes beauty? Do we want an intelligence that sees humanity as a problem to be solved, or as a species to be nurtured and empowered? The kind of AGI we build will be a testament to our own values, so what do we value most? That is the question that remains. And the answer we choose will define not only the future of technology, but the future of humanity itself.